NEC 300.7 addresses the need to prevent the circulation of warm air to colder sections of raceways. This requirement aims to minimize condensation within the conduit system. Condensation can lead to corrosion and potential electrical faults. The specific question is whether this applies to conduits that exclusively carry communications wiring. The answer is no. NEC 300.7 primarily focuses on power conductors and their associated raceways, where temperature differentials and potential condensation pose a significant risk to the electrical system's integrity. Communication circuits, while still subject to general wiring practices, are not typically considered to be within the scope of this specific requirement. This is because communication cables generally operate at lower voltages and currents, reducing the risk of condensation-related issues compared to power conductors. However, it's crucial to understand the full context of the NEC and other applicable standards to ensure the safe and compliant installation of all wiring systems, including communication systems. Here is a more detailed explanation. NEC 300.7 exists to deal with the physical phenomenon of condensation inside raceways. When warm, moist air enters a cooler raceway, the moisture in the air can condense into water. This water can accumulate and cause corrosion of conductors, damage insulation, and potentially create short circuits. Power conductors, due to their higher voltage and current levels, are more susceptible to problems caused by moisture and corrosion. The NEC mandates sealing or other methods to prevent this air circulation and condensation in power systems. Communication wiring, on the other hand, transmits data or signals at relatively low voltages and currents. The potential for damage from condensation is significantly less. While good workmanship and preventative measures are always recommended, NEC 300.7 is not explicitly enforced for communication conduits. It is essential to consult Article 800 of the NEC, which specifically addresses communication circuits. Article 800 outlines the requirements for installing communication cables and equipment to ensure safety and proper function. It covers aspects such as wiring methods, grounding, and protection from overvoltage and overcurrent. While Article 800 does not directly invoke NEC 300.7, it does emphasize the need to protect communication cables from physical damage and environmental factors that could impair their performance. Furthermore, local codes and regulations may have additional requirements for communication wiring systems. It is always best practice to consult with the local authority having jurisdiction to ensure compliance with all applicable rules. Consider the specific environment in which the communication wiring is installed. If the conduit system is exposed to extreme temperature variations or high humidity, it may be prudent to take preventative measures to minimize condensation, even if not explicitly required by NEC 300.7. These measures could include sealing the conduit ends, using moisture-resistant cables, or providing ventilation to reduce humidity. Additionally, consider the type of communication cable being used. Some cables are more susceptible to moisture damage than others. Select cables that are suitable for the intended environment and that are listed for use in wet locations if necessary. A proper understanding of the NEC and other relevant standards is critical for ensuring the safe and reliable operation of electrical and communication systems. Always refer to the latest edition of the NEC and consult with qualified professionals when designing and installing wiring systems. Consider the practical implications of condensation within electrical raceways. The effects can range from minor inconveniences to significant safety hazards. Firstly, corrosion is a major concern. Water accumulating inside a raceway can corrode conductors and metallic components, increasing resistance and potentially causing overheating. Secondly, insulation breakdown can occur. Moisture can degrade the insulation of conductors, leading to leakage current and potentially creating short circuits or ground faults. Thirdly, equipment malfunction is possible. Water can damage sensitive electronic equipment connected to the wiring system, causing malfunctions or failures. Fourthly, safety hazards can arise. Short circuits or ground faults caused by condensation can create electrical shock hazards for personnel. Fifthly, increased maintenance costs will result. Regular inspections and repairs may be required to address corrosion and other issues caused by condensation, increasing maintenance costs. To mitigate these risks, several preventative measures can be implemented. Firstly, sealing conduit ends can prevent the entry of warm, moist air into the raceway. Secondly, using moisture-resistant cables can protect conductors from corrosion and insulation breakdown. Thirdly, providing ventilation can reduce humidity within the raceway system. Fourthly, installing drain fittings can allow accumulated water to escape from the raceway. Fifthly, using corrosion-resistant materials can minimize the effects of moisture on metallic components. Here are some additional points related to communication wiring systems. Firstly, grounding is critical. Proper grounding of communication systems is essential for protecting equipment and personnel from electrical hazards. Secondly, surge protection is necessary. Surge protection devices should be installed to protect communication equipment from voltage surges caused by lightning or other events. Thirdly, cable management is important. Proper cable management practices should be followed to ensure that communication cables are not damaged or subjected to excessive stress. Fourthly, labeling is recommended. Communication cables should be labeled to identify their purpose and destination. Fifthly, documentation is valuable. Accurate documentation of the communication wiring system is essential for future maintenance and troubleshooting. The National Electrical Code serves as a comprehensive guide for safe electrical installations. It is important to stay up to date with the latest edition of the NEC and to consult with qualified professionals when working with electrical systems. The NEC is updated every 3 years to reflect changes in technology and best practices. It is essential to use the latest edition to ensure compliance with current safety standards. Here are some additional considerations for specific types of communication wiring. Firstly, for data cables such as CAT5E or CAT6, it is important to maintain proper bend radius and avoid kinking the cables. Secondly, for fiber optic cables, it is important to handle the cables carefully to avoid damage to the fibers. Thirdly, for coaxial cables, it is important to use proper connectors and termination techniques. Fourthly, for low-voltage control cables, it is important to use cables that are rated for the appropriate voltage and temperature. Fifthly, for telephone cables, it is important to use cables that are designed for voice communication. In summary, while NEC 300.7 does not directly apply to communication wiring, it is important to consider the potential for condensation and to take appropriate preventative measures to protect communication cables and equipment from damage. Always refer to the NEC and other applicable standards to ensure the safe and compliant installation of all wiring systems. Furthermore, consider the impact of electromagnetic interference, or EMI, on communication systems. EMI can disrupt the transmission of data and signals, leading to errors and performance degradation. To minimize EMI, consider the following measures. Firstly, use shielded cables. Shielded cables can reduce the amount of EMI that is coupled into the communication system. Secondly, separate power and communication cables. Power cables can generate significant EMI, so it is important to separate them from communication cables. Thirdly, use proper grounding techniques. Proper grounding can help to reduce EMI by providing a path for unwanted currents to flow to ground. Fourthly, use filters. Filters can be used to block EMI from entering the communication system. Fifthly, follow good cable management practices. Proper cable management can help to reduce EMI by minimizing the length of exposed cables. In addition to EMI, consider the impact of electrostatic discharge, or ESD, on communication systems. ESD can damage sensitive electronic components, leading to equipment failure. To minimize ESD, consider the following measures. Firstly, use ESD-safe workstations. ESD-safe workstations provide a controlled environment for working with electronic components. Secondly, use ESD-safe tools. ESD-safe tools are designed to prevent the buildup of static electricity. Thirdly, wear ESD-safe clothing. ESD-safe clothing can help to prevent the buildup of static electricity in the body. Fourthly, handle electronic components carefully. Avoid touching the pins or leads of electronic components. Fifthly, ground yourself before handling electronic components. Grounding yourself can help to discharge any static electricity that may have accumulated on your body. The safe installation of communication wiring and electrical systems necessitates a comprehensive understanding of relevant codes, environmental factors, and potential hazards. While NEC 300.7 primarily focuses on preventing condensation in power raceways, it is crucial to consider the potential for moisture-related issues in all wiring systems, including those dedicated to communication. By adhering to best practices, utilizing appropriate materials, and implementing preventative measures, professionals can ensure the reliable and safe operation of these systems.